I'm Kunihiko.
And Tsuyoshi Horo.
Yeah, that's us. And okay, let's just dive into the slides. So let me just start off talking briefly about who's working on ServiceWorker. So yeah, we have a big team in Tokyo, the Google Tokyo team. So as you've heard throughout other presentations, we're kind of organizing Blink contributors in these teams, which are like long-term owners of areas of code. So ServiceWorker falls under the workers team, which is takes care of worker threads, of which ServiceWorker is one. But also we have many contributions from outside of Tokyo, like San Francisco, Mountain View, Cambridge offices, and yeah, it's also cross-company as well. Very significant contributions from Intel and Samsung as well. So it's a pretty big, distributed, complex team. And as for spec work, it's done on GitHub at that link. Participants include Google, Mozilla, and Samsung. Probably among others. I'm probably forgetting some people, but okay. Oops. So let me just start like a brief introduction to what ServiceWorker is. So conceptually, it's quite simple. It's a type of worker thread that runs in the browser, in the render process. Basically, the browser wakes it up whenever it wants to dispatch an event to it. So the ServiceWorker is a thread that responds to these events that are kind of driven by the browser. And the important property to know about service workers is they're transient. So they wake up when needed, when the browser wants to send an event. And when when it doesn't have events to handle, the browser can kill it. So it's this transient thing, which is different than other worker threads we have. But it also has a persistent side to it. So a service worker gets installed into the browser. A site would install a service worker. It would go through an installation process, and once it's installed, then it persists in the service worker registrations box in the browser. So this is what lets the browser, wake up service workers that are not running. You can close the browser and open the browser again, and when it needs to wake up the service worker, it looks in the registrations for what the service worker script is, and can spin up the new service worker thread. And the service worker itself can also has access to persistent data storage called the cache storage. So this is a new kind of storage mechanism designed for service worker originally. It stores HTTP requests and responses now, although the cache has now been exposed outside of service workers, so websites, the window can use it as well, and it's like keyed by origin. Okay. So that's the concept of what a service worker is. So let me talk about what you would use service worker for. So one big use case is intercepting browser network requests. So these manifest as the onFetch request, the onFetch event, or I guess the fetch event, which the service worker can handle. So when the browser wants to do an HTTP request, it would see that a service worker is registered to control this type of URL, and yeah, so the browser, the service worker onFetch event handler would run, and the service worker can respond to the request. Usually, this would involve the cache that you saw in the previous slide, or it can fall through. It can just do nothing, and the request would go to the network as usual. It can also do other things like respond with another URL, in which case it wouldn't really be fall through. It'd be like go to this other URL, and the browser would use the response from that URL to respond to the original one. So that's one like big use case of service worker. The other big one is push notifications. So this is a bit more complex. So the site would register, it would just subscribe for push notifications with the push server. In Chrome's case, Google Cloud Messenger, although Probably in the future there will be like a more standard API, and other browsers can use other servers. But Chrome right now, GCM. So in this example, example.com would have subscribed to receive pushes. And so push registration, you would need to have a service worker installed on your origin in order to use the push. So the push registration is associated with the service worker registration. So yeah, what happens when example.com wants to push something to the browser is listening to GCM. GCM would push data to the browser, and this turns into a push event. So the service worker, which may not have been running at that time, gets woken up, and it receives this push event. Typically in response to, I think actually it must, in response to push event, show a notification. So it does this by, it tells the browser, please show the notification for this push. And then when the user clicks the notification, that turns into another event sent to the service worker. Typically in response to this, it would ask the browser to open a window or focus an existing window for that site. And then the browser process would send that to maybe this render processor or another one to open a window and show what the site wanted to show. Okay. So yeah, that's kind of a overview of what Service Worker is and what it can do. So let me talk about like our status, what we've implemented since the previous BlinkOn. So the biggest thing is that it shipped in M40. So yeah, it's good. So yeah, Chrome 40. Since Chrome 40, service workers can be used in the wild. What we shipped, we call the MVP, the minimal viable product. What this was basically it allowed the offline use case. So fetch, basically HTTP request interception, the fetch API and the cache API, those all combine to allow a service worker to be like an alternative to app cache. The next big milestone was M42, which is when push notifications shipped. So these were built on top of Service Worker and mostly done by a different team. The London team in Google did most of the work for this, although we had to support the needed APIs that they were using in Service Worker. So that was the other big thing. And then since then, we've been sort of looking at, what are the main complaints among developers trying to use Service Worker, and the biggest one was actually our developer tooling. It was very difficult to actually develop service workers, particularly with the complicated installation and update flow, was just really not exposed anywhere in our DevTools. You could always inspect an individual running service worker, but that was not really sufficient for doing development. So our big push lately has been on DevTools. I just listed some improvements that are either ongoing or shipped here. So a better UI, particularly to show the life cycle of a service worker, and installations and updates, as I just mentioned. Better inspection of the service worker cache and deletion of cache entries. Yeah, and as a HTTPS only feature, it's hard for developers to I don't know, develop locally if they have a complicated server that they need to set up. They just need an easy way to get around the HTTPS restriction for local development, and we're working on that. And yeah, etc. A lot of things were needed to get this to be appetizing to develop on. Okay, next slide. So yeah, just talk a little bit about how it's been received. Push notifications were a very big deal among web sites. So yeah, as the headline says, big sites like Facebook, eBay are planning to support and are actually starting to support already push notifications. So the adoption of Service Worker has been very fast and good. Yeah. And yeah, it's not just Chrome developing it. Also, Firefox are now supporting for service workers in their nightly. So not shipped yet, but a working implementation exists in Firefox. And this last headline is about an enhancement to Chrome's Add Home Screen feature. So when a site has a service worker installed and it passes other criteria to be a good candidate to add to the home screen, Chrome will spontaneously show a pop-up saying, do you want to add this website to your home screen? The reason service worker is part of that criteria is it's a good indication that the site works offline. So you don't want to have an app on your home screen that doesn't work offline. It wouldn't make much sense. Okay. So that's all kind of overview, concept, and status. So now I'd like to go into like how the inner workings of service worker, like what actually happens when the browser tries to wake up a service worker, and how the actual like URL interception works. Any questions so far? You can also take questions at the end. Okay, so let's just go into how service workers work. So we'll start with this scenario. The browser is running and it wants to dispatch an event to the service worker. And the worker is not running at this time. So what happens? Okay. So the browser needs to first find a renderer process. So either one exists that's suitable for running a service worker in it, or one is not. If it's not, then one will be created. And the browser will ask that renderer to start up the worker thread. Okay, and then so what happens next? So the renderer at this point, all it knows is like, it doesn't, all it knows is the service worker script URL. It doesn't know like what the actual script is, because service workers are transient and stored on the browser. So what the renderer is going to do is try to load that URL, for example, example.com/serviceworker.js. So and then to load something, the renderer needs to have a page just for loading works, just so that loading can work. So it creates what we call like a shadow page, which is just this empty frame that's never displayed. It's only used for loading. And so this goes through the Blink loader and up to the browser's network stack, trying to request the service worker script. But we're obviously not going to go to network to download this service worker, because it has to work offline and we already have it installed on the browser. So the browser actually intercepts this network request using the same machinery as the fetch, the thing that creates the fetch events. So yeah, we hook in at the network level in the browser, and we see that this is a URL request for a service worker script. So a service worker class handles this request, and it looks in its registrations for it, and it reads the script from the database. Okay, so after the script's read, loading is complete, and the service worker thread can start running, and it will execute the service worker script. And yeah, so this happens every time the browser had to wake up a service worker. So finally, when the service worker finished executing the script, it tells the browser, yes, I was started successfully. And recall, like the whole reason for this was that the browser wanted to dispatch an event to the service worker. So now that worker start was successful, now the browser can tell the renderer to dispatch this event. We'll say a fetch event, for example. And the service worker's fetch event handler will run, and it will respond to the fetch event from the browser. Okay, so that's like the workflow to dispatch a event to a service worker that was not running. Okay, so the next thing to talk about is like, how does this actual URL request interception work? So like why the browser knew to dispatch a fetch event to the service worker, and what it does with this response. Okay, So let's just dive into that. So typically, network, loading works as kind of this pipeline. The renderer wants to load something, it's presented, or the Blink wants to load something, it's presented to the embedder as a web URL request. It goes through the Chrome's resource loader and up to the network stack as this URL request. And then this thing does whatever it needs to do to read from the network. And this is where the service worker interception occurs. Yeah, basically the network stack has these things called interceptors, which lets you custom handle a request. So in service worker's case, we've registered a request handler, and this gets consulted, I think, on every URL request, but most of them it will choose not to handle unless it's associated with a service worker in some way. So if this should be handled by a service worker, then we will say yes, I'll handle this request. So to handle a request, it creates what's called a URL request job. All URL requests are handled by this job system. So this is just one for service workers. So what our job will do is find the version that should receive this fetch event. So it'll either be the service worker registered for this URL pattern, or it'll be the service worker controlling the page that spawned the request. So, and then, yeah, from here, the fetch event is dispatched, and that whole set of waking up the service worker and dispatching that we just saw might occur if the service worker is not running. Okay, so now the service worker has a choice of what to do when it receives this fetch event. It could either do nothing, so maybe it didn't even have a fetch event handler, or it did have one, but it didn't call respond with, and it just basically didn't respond to this request. So in this case, the renderer will tell the browser, no, fall through, I didn't do anything, and this goes back up to the network stack, and the request handler will say, yeah, I tried to handle this, but actually I can't, so please retry without me. And then the typical network happenings occur. So the other thing the service worker could do is obviously respond. So a response would consist of a status code and headers, obviously. But the interesting thing is how response bodies come in. So one thing it could do is respond with a blob. So in this case, the worker would give a blob UUID back to the browser, and the browser knows how to read these UUIDs. It spawns another request job called blob request job, which will read this blob. So now the question is, why did the service worker know what this blob UUID is? It's this transient thing with no no storage inside the render. So where did this blob UID come from? Typically, it comes from cache storage. So if the service worker responded with, caches.match, so this is basically saying, oh, look in the cache for a response for this request. What happens is, so the fetch event happened here, and the service worker goes back to the browser and asks to match this request from cache storage. Cache might find the request in its cache and respond with the UID, and that's what ultimately goes back to the URL request job, and that's how a response, we go back here, and that's how the cache response is actually read. Oh no, that's not what I meant to do. Okay, so that's responding with the blob. The other interesting thing a server can do is respond with a stream. So in this case, the worker would respond to the browser with what's called a stream URL. This is an internal representation of identifier for a stream, and it would be read from what's called the stream registry in the browser. So again, the interesting thing is, how did service worker know what the stream URL is? And I think this is the most complicated slide of the talk. So in this case, the stream would come from fetch API. So the service worker can respond with like another URL, or even it could be the same URL as the original request. So what happens in this case, we start at the fetch event. So since the worker calls fetch, we go to the fetch like API, and this goes back up to Chrome's like network stack. A web URL request is presented to the embedder. This goes to the resource loader and up to net URL request. And this does its thing to read from the network. And this goes back into the render progressively into this memory buffer. And this gets sent up back to the browser into the stream registry. And when the fetch promise resolves is when the worker thread responds to the browser with the stream URL. And finally, when all that happens, the browser can read the data from the registry. So I think there's some optimizations that we can do to simplify this. But this is the current implementation now. And we'll talk about some performance plans after this. Okay. So yeah, that's the next slide. What's next for ServiceWorker? Let's go into this. Yeah, so I'm not going to talk about like every single thing, but just some key like areas and some issues in each area. So one of them is security. So the way ServiceWorkers hook into the network stack creates kind of this issue within Chrome. Like you have this URL request and response, but the Chrome doesn't actually know whether a service worker had provided the response to this request. So to code that doesn't know about service worker, it looks like a response for origin A came from origin A, which was a reasonable assumption to make before, but now with service workers, it could have come from a service worker on B, or a service worker on B could have asked origin C to provide a response for this. So there's some ideas being floated around on how to fix this. One is to change where the service worker hooks into the network stack. So right now, it's hooking in up here at the URL request level, which is what's creating this confusion. When you have this URL request and response, you don't really know that the service worker had intercepted it. So if the hook in happens lower down, so maybe at the resource loader, then just the network stack is at a different layer than service worker, and your problem goes away. Or you can even move it lower down into Blink or something like that. That's kind of a optimistic idea. The problem is like it would just involve major code changes to how service workers work. The service worker uses a lot of like the code of the network stack, which would like go away if we put it at a different layer. Another problem is a lot of web platform features like app cache, blob, file are at the same level at the URL request. So it would be kind of inconsistent if service workers at a different level, and if it had to re-implement a lot of stuff that it wanted to use previously. So maybe that's the solution, but it would involve a lot of effort to fix. Another idea is to teach the network stack about service worker. For example, it already keeps track of redirects. So maybe like, if service worker is intercepted, you can kind of like a redirect say, service worker interception happened at this point, and then maybe a redirect happened, and then another service worker interception at this point. So you have kind of a chain of history of what happened to your request. But that idea is also not very simple to implement as well, and an argument can be made that service workers shouldn't sit at that level of the network stack. So this is an open issue. We're still trying to figure out. We still need a solution. And so for performance, I'm going to stop talking and let
So let me talk about service worker performance. We are collecting UMM metrics for service worker startup time and event execution time for service worker related events. So for new service worker, the startup process will be like this. First, allocate a process for service worker and download worker script and evaluate the scripts, and then dispatch install events and activate event. For installed service worker wake up, the process is process allocation and script load from local database and script evaluation, and then dispatch some events that cause script wake up, service worker wake up. For example, fetch event or push event. Okay. So let's see the numbers. Start new worker is the overall startup time of new service worker. That takes 477 milliseconds in the median. And start worker is for installed worker startup time. And process allocation is pretty fast. And script load from network, it's a major part of starting new worker. And script load from local database is faster than downloading from networks, of course. And script evaluate is initial evaluation of worker script. And install event can take a long time if the worker fetch some resources from networks. And activate event, this is for cleanup of all the caches used by previous versions of service worker, but it seems not used very much right now. And fetch event also is very fast. That means the request falling through the network. For push only service workers, they may not handle fetch event at all. So yeah, that's fast. And another topic on performance is performance timeline API that provides access to timing information from JavaScript. For example, navigation timings, resource timings, and user-defined timings. Basically, that's the information you can see, on the network timeline of DevTools. But currently, for service worker controlled pages, performance timeline API is not very useful because for page contexts, we lose detailed request timing data due to service worker interception. And in the service worker context, there is no access to resource timings. Resource timing is not exposed to worker global space right now. So we direct to implement service worker support of performance API. There are three parts, and first one is offer resource timing in service worker that provides information for resources fetched by service workers. And second part is for user timings in service worker that allow developers to instrument and measure service worker execution time. And third item is add worker start attributes for navigation timing and resource timing. This is for page context, not service worker context. That makes service worker start uptime measurable. And all necessary spec changes have been made, so we plan to implement it in M45. Next, Matt.
Okay. So yeah, just some other performance ideas that we have. Smarter waking up of service workers, for example, like a service worker that doesn't even handle a fetch event, we probably shouldn't be waking up and dispatching an event if nothing's going to happen. And a lot of service workers in the wild are basically just for push notifications. So if we can, recognize those types of service workers, we can do other optimizations possibly. For example, not even doing like the whole like URL request interception if it's this type of worker. Smarter event scheduling. So right now, just when the browser wants to send an event to the service worker, it just sends the IBC to the renderer. So maybe we can do smarter things like integrating with the Blink scheduler to send these events at appropriate times. We also need to do better investigation and understanding of like our memory and battery performance. And the battery is kind of related to like smarter wake up time and smarter scheduling, stuff like that. And I think next, oh, okay. And then, yeah, so another area that we're working on is the reliability of service workers. We're actually seeing a problem in the wild where a lot of the time a service worker fails to start up. We think this is because its script, which is stored in the block file disk cache of Chrome, just got deleted, or the disk cache got corrupted, and the script is just gone, so we can't start up the worker. Our plan is, in addition to adding mitigations like better recovery when this happens, migrating to a more reliable storage called Simple Cache. Yeah, the block file disk cache is what's used for just caching your HTTP cache of the browser, which probably wasn't really built to be like super reliable. So maybe moving to a different cache system would be better for service worker. Yeah, and then better recovery when like corruption like this happens, or if the service worker database gets corrupted. Just work to lower the probability of that happening, and maybe have smarter recovery mechanisms. Another big thing is just safer threading in Blink. So yeah, Blink historically has been written for like single-threaded code, although like with workers and service workers, this is changing. But a lot of Blink is not thread safe. So Kunihiko actually sent out a document, I think, yesterday or 2 days ago, a good design doc at this link if you're a Googler, or just search on Blink Dev for thread safe Blink. You'll probably find her post. Yeah, the idea there is just to make more of the code thread safe, particularly with strings. Like Blink strings are not thread safe, and they're used by all sorts of classes. So we get into problems as more workers, like service workers, are running. Another thing is that there's no reliable way to terminate a worker thread right now. Well, there is, but then code afterwards can start crashing because V8 like returns null on some function calls which are not checked, or the caller doesn't expect a null to be returned. So there's ongoing work there just to make Blink threading more safe. Okay, and then Horo-san can talk about DevTools.
I want to talk about service worker related DevTools features. From milestone 40, when we launched ServiceWorker, we have Chrome ServiceWorker internals page, which is a debugging tool for Chromium Blink developers like us. We can inspect the internal state of ServiceWorker, such as version ID or process ID. But this is not user-friendly for web developers. Web developers don't need to know such renderer process ID or source internal state. And from milestone 43, service worker can be inspected from the DevTools page of that page. Thank you. Web developers can debug service worker script in this page. This is a Google I/O homepage, which is using service worker. There is serviceworker.js in threads panel, and we can set the breakpoint in this service worker script. And also we can execute the JavaScript code here. in console panel. And also, we are developing service worker inspector page. We can inspect the state of service worker with it. And for example, we can delete the service worker registration and update the registration and emulate the push notification message by clicking this button. This page is better user-friendly than the service worker internals page, I think. And also we can use this page while remote debugging Android Chrome. I think it's very super useful. Thank you. But this service worker inspector is available from 43, but it's still an experimental feature. So if you want to use this, you have to change the settings like this. Open Chrome flags and enable DevTools experience flag and restart Chrome and open DevTools and setting experiments and hit shift key 6 times and enable service worker in those panel and reopen DevTools. If you do this, you can use this inspector. And current user interface design is not fixed yet, and feature requests and bug reports are welcome. And we are planning to this feature in milestone 45, hopefully. That's all from me.
That's actually all. Yeah, that's all from us now. So yeah, any questions? You can also reach out to BlinkDev if you want to ask about ServiceWorker. We don't have a dedicated mailing list, but historically we've used BlinkDev.
What happens to running ServiceWorkers on Chrome?
Oh, if what?
They're like Chrome is killed and restarted. Will ServiceWorkers restart?
Oh, yeah. Oh, I have with mic. Yeah. So the question was, what happens if you had running ServiceWorkers and then Chrome restarted? So yeah, the ServiceWorkers would not be restarted because they don't have an event to handle.
But they'll still be registered?
Yeah, they'll still be registered. Yeah.
And what happens in a world where every page you visit has a service worker?
Then yeah, they'll be woken up every time. Yeah, I mean, if every page has a service worker, I mean, so when you navigate to a site using the service worker, then you would wake up the service worker if it was not running. When that service worker goes idle, we'll kill it. So if you're like, usually you would only have like a handful of service workers running at the same time, because if it hasn't done anything in a long time, then we just.
But you're caching all the scripts, right? Yeah. So eventually that could theoretically become burdensome.
Oh, just in terms of storage, yeah. Yeah, we haven't thought about evicting like service workers from the cache yet. We don't have that problem yet. It might happen.
But this wouldn't affect the startup time of Chrome?
It would not. I don't believe it would. Oh, well, okay. So the new tab page, I mean, yeah, if new tab page use service worker, then, I mean, I guess it depends what happens on startup. If your startup will open all these tabs in a folder tabs run and a folder tabs were using service worker, then yes, we would use the service worker. You would wake up the service worker on every tab, and that could affect startup time.
So you're not storing any state on storage and then pulling it back up on startup?
Yeah, there's no state stored beyond the service worker script and what was stored in the cache storage.
Okay. So I have a couple of questions. So I noticed that process allocation said, I think, 30 milliseconds on Android. I was a little bit surprised on that because I thought sort of processes were really expensive on Android. So how are you able to bring that down? Is that creating a new process? Is that what that means?
Sorry.
Yeah, in typical case, the process allocation is pretty fast. 1 millisecond, just 1 millisecond. But in the slower case, it takes about 30 milliseconds. I don't think it creates process every time we can reuse existing render process if possible.
Right. Yeah. This is kind of a misnomer. It's really find, process, or allocate. So
Yeah.
sometimes it's finding, sometimes it's allocating, and yeah, maybe we should split those up to have a better understanding. Sure.
So I'm wondering, so this all looks a lot like kind of the extensions, web request API, and I'm just wondering, you're doing a ton of, sorry? Yeah. I'm wondering, like, with all the process hops and the fact that you're creating a process and so on, like that could have implications sort of for battery life. And I'm wondering if there are maybe common patterns that developers might use, and perhaps you can implement sort of a declarative version of it where you don't need to start a new process. So you can say under certain circumstances, just do the push notification.
Hi, Alex Russell. I work on the spec side of the ServiceWorker system. So there were a couple of parts to that question, and I'll try and answer them in order. With regards to a declarative version, we have explicitly in the V1 of the design pushed out all declarative features and done a pure imperative version, because the predecessors to ServiceWorker were things called Gears and App Cache. And Gears and App Cache both had very declarative versions, which in theory solved a bunch of problems, but in the real world turned out to not be flexible enough to solve developers' issues. So we're paying close attention to the metrics that come back about what people are doing, and we want to get better data in the future about how people are using the system. Once we have large deployed sites, we plan to go talk to them about how they're using it and the trouble that they're having to try to add new features to this minimum viable product. For instance, you could imagine an API that we could put in the installation phase, which would let you directly map potential requests to cache entries. That's one area where we could potentially be more declarative and have an intermediate area. It's something we've thought about a lot. In terms of, I'm not authoritative on this, but in terms of the process creation and runtime cost, in almost every case, the ServiceWorker script for an origins content will be running in a separate worker thread in the same process as the document that's being displayed. The cases where that's not true, or where you don't necessarily have a document. So for instance, waking up in the background to handle a push message is a case where we wouldn't necessarily have a document but we have to do that work anyway in Navigator.connect. The other part of your question, the last part, was about, could we do a declarative version of push notifications? And we looked hard at this and decided not to do that, because the experience of declarative push notification systems, of which there are some in the world, is poor, because users frequently will get a notification with some content in it, tap the notification, and then find themselves launching a web page which doesn't work or doesn't have the data, and then they have to wait for the data. The model that we presented in the push notifications API flips that on its head. It requires you to go to the network for the thing that you were going to show, and hopefully that means that you will have had time to go update your database, so that when you tap the notification, not only will you have a local copy of the app, but you'll also have the local data. We are, as an optimization step, adding a body to the push messages to help make it easier to display latency sensitive data in the near future, but that's designed really only to be an optimization.
Any other questions? Okay. Yep. Okay.